Okay, next we're going to cover the area of a sector. So they give you that formula in the book, and I have it in the notes, but I'm just going to show you here in the video where that actually comes from. Okay, so basically you've got a whole circle and you have a part of a circle, which is what the sector is. It's a piece of the whole piece of pie or a piece of the circle. You can think of that as looking at this. The area of a circle divided by the angle it would take to go all the way around the entire circle. So that would be a full circle would be 2 pi radians. So area of a circle over 2 pi radians would be that. However, we also have the area of a sector, and we're going to divide it by whatever this particular angle is. This will be the whole angle, this will be part of the angle. What I want to do now is I want to solve for the area of a sector. However, this part, area of a circle, we have a formula for that. That's going to be pi r squared. So pi r squared will go in there, and we have 2 pi down below here. That's going to be equal to the area of a sector, and that's going to be divided by theta, and theta would be the central angle that you would have for that particular piece. What I now want to do is I want to cross multiply, and eventually I'm going to solve for the area of a sector. So I've got area of a sector times 2 pi, that's this part, is going to equal these two things. That's going to be pi r squared theta. Well, now I want to solve for the area of a sector, which means I would divide both sides by 2 pi, and then I get this, the area of a sector, I'll just call it big A. That part cancels. Right here, the pi's cancel there, and you get 1/2 r squared theta. So this right here is the formula that we're going to use for the area of a sector. Now you must note that this has to be in terms of radians also. So just like the arc length formula, this also requires us to have it in terms of radians. So now that we've derived the formula for area of a sector, now let's take a look at some example problems. Okay, so now we're going to do an application of the area of a sector. We just talked about where the formula came from, so now we're going to apply it here. Find the area of a sector with a radius of 4 inches and a central angle of 4 pi over 3. Here's the formula. Area equals 1/2 r squared theta. Again, your theta must be in terms of radians. Well, we have a central angle. That's your theta. That is in terms of radians, so we're going to put that in here. Also, the radius is going to be 4 inches. Area equals 1/2. You're putting in a 4 in here. Now, technically, when you're putting that in, we have 4 inches, and we're squaring it, and you're multiplying that by 4 pi over 3. I talked about this before in the arc length video. We say that your radian is actually a dimensionless unit, so it means that my units on this answer are going to be inches squared. They're going to come from here. So we have area equals 1/2 times 16, that's going to be inches squared over 1, and then I have 4 pi over 3 was our radian measurement that we put in. So now we want to simplify this. Okay, 2 goes into 16, that's going to be, we're left with 8, and we multiply across the top, across the bottom, and what's left is 32 pi over 3, but our unit is going to be inches squared because originally we had the inches here, we're squaring it, and that's how we got square inches. And any kind of area, if you talk about even like square footage of a house, that's in terms of area as well as square footage, so that's why we have that as our unit. Okay, another one, we'll do the area of a sector. We have a radius of 6 inches and a central angle of 150. We want to find the area of a sector, so here's the same formula we used before. In the previous example, 1/2 r squared theta. Now for this, in order for you to use this formula, we first have to take 150 degrees and change it over into radians, because this formula only works with radians. That's what we'll do first. 150 degrees times pi over 180 degrees. When we reduce that, you get 5 pi over 6. So 5 pi over 6 would be the radian measurement. That's what we're put in for our theta. So I have 1/2. My r was 6 inches. I have 6 inches, and I'm squaring that, and then I'm multiplying it by theta. So your theta is 5 pi over 6. Okay, so now we're going to just work this out. Now when I square that, I get 36 inches squared. My units got squared on that. and I have times 5 pi over 6. So what you can do here is you can reduce this. The 6 goes into 36 6 times. It'd be 6 times 5 is 30 over 2. That would give you 15 pi would be the answer. And our units would go down with that as well, inches squared. We talked about it before in the arc length video. Again, this is a dimensionless unit, so that's why the inches squared kind of comes down there. And that would be your final answer. And that makes sense because if you're talking about area like covering a room with carpet, we have square feet on that because that's referring to an area. That's the same idea here. So this is going to be square inches. So this is basically how much space is taken up by that piece of the circle, how much is taken up by that piece of pie, that sector.